Hello, this is Mr. Craig, and I wish to work out the problems for factor label worksheet number 3. But before we can start to work on that, let's make sure that we understand the Great Mega King. And I would highly recommend that before every single quiz or test that you're doing factor labeling, where you're going from metric to metric and doing these conversions, put this chart at the top. Again, the statement goes, the Great Mega King one day caught me microwaving nasty pizza. And let's go ahead and change the color here. And so make sure that you remember the values having 10 to the 0, 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, and then, I'm sorry, once you go 0, 1, 2, then it just goes 3, 6, 9, 12 all the way out. So negative 6 here, negative 9, and negative 12. And then on this side, on kilo, 10 to the 3, 10 to the 6, 10 to the 9, and 10 to the 12. So making sure that you know those values is really important. And again, it all stems from the 10 to the 0. Now, again, when you are going from one place to another, say if you're going from giga to, say, milli, it's how many times you move the decimal place once you get to there. So it's not counting letters. So I'm not going 1, 2, 3. Don't do that. That's a bad habit to get into. It's how many decimal places do you count over when you're actually determining these values. Also, keep in mind that when you are looking at, say, let's get this different. Now, when you're looking at 10 to the 0, this represents grams, liters, and meters. So notice that there's no prefix in front of these things, because the prefixes actually come from here, and they represent something specific. Okay, so don't necessarily go crazy and ask yourself, well, why are there no subscripts here? Because, again, they're all by themselves, and we are looking at 10 to the 0. Okay, so let's go ahead and take a look at those, and let's look at the first problem. Okay. So question number 1 says you have 325 gigameters, and it wants to know how many nanometers. Also keep in mind that you will always be provided the conversions when we go from metric to English. So that will always be given to you. And the only thing that you have to memorize is really the Great Mega King. So let's take a look at the first question. Again, always ask yourself, what information am I given in the question? Well, in this case, you're given 325 gigameters. So start with what you know. So you have 325 gigameters. And this is a metric to metric problem. So what that means is, if the unit that you were given, like in this case, gigameters, is not what you're looking for, you're going to move that unit diagonally. We want to put gigameters down here because we have the unit in the numerator and the denominator, and those will cancel out. So that's why we always want to do that first and foremost. So again, move your gigameters down. So that means that we're going to be looking at gigameters down here. And then I'm going to go ahead and erase this guy here. Whoops, sorry, undo. Sorry, I got used to this board. So we can get rid of this off to the side here. And since I am looking for nanometers, and yes, nano and giga are metric, so that's a good thing. So we can say, hey, this is a metric to metric problem. Next thing you need to do is ask yourself, well, which of these is actually bigger? Well, again, whichever unit is farthest to the left is actually the larger of the two. So we give that value the unit 1. So we'll assign gigameter the value 1, and since this is metric to metric, then we're going to figure out what our coefficient is. So going from giga to nano means that we're going to go from 10 to the 9. Go ahead and get a pen here. So we're going from 10 to the 9 all the way over to 10 to the negative 9. So if I'm moving my decimal place the right or the correct number of times, I start at 10 to the 9 and I finish on 10 to the negative 9, That means I've moved my decimal place 18 total times. Okay, so we want to reflect that information accordingly. So we want to, let me zap that real quick. Okay, so we would put an 18 right here. Again, going from giga to nano. So giga 10 to the positive 9, nano 10 to the negative 9. So that's how we get that value there. Now that we have our units that cancel out and we have the unit that we're actually looking for, we can do our calculation. So when typing this information in, again, 325 times, however it is that you do your 1 times 10 to the positive 18. And again, no negative exponents within the problem. And again, this is within the question or within the problem. So within the problem is right here. Notice that we have conversions. So we got conversions on top and bottom. There's no conversion here. So we wouldn't, it's okay to have a negative here if I had it, but I don't. So let's go ahead and zap that. Some of those lines. So no negative exponents within the problem. Okay? All right. And one more. So the way you, again, you would type it in 325 times, and I just do 1 EE 18. And again, some of you might have an EXP button. Some of you may want to just change this whole thing and say, you know what, I'm going to do 10 caret 18. That's fine, but don't do, never ever do 10 EE 18. That would be bad. Okay? So when we type all this information in, what value do you get? Hopefully, after you type that in, you said, okay, well, I've got 3.25 times 10 to the 20. And again, your units are in nanometers. Okay? Let's look at question number 2. Again, we have a metric to metric because I have liters going to milliliters. So start with what you know. Okay? So I know I have 75 milliliters. Start off with my 75. Sorry, I have 75 liters, my bad. And I am going to move my unit diagonally. So I'm going to move liters diagonally and put it down in the next spot or in the denominator in the next location. Also, again, since this is metric to metric, I can put milliliters right on top. Now again, which one's bigger? Well, liter is located at 10 to the 0. Milli is located at 10 to the negative 3. So liter is much bigger. Okay? So we want to go and say, okay, liter gets the value 1, and then milli gets the value of 10 to something. So going from liter to milli is a process of moving 3 times. So it's 10 to the 3, or 1,000. So in this case, we would get 75,000, or in scientific notation, 7.0 times 10 to the 3. Sorry, to the 4, my bad. To the 4 milliliters. Okay. All right, so let's take a look at, and again, these metric to metric conversions should be automatic. We should have no issues with it. And they'll be automatic if you have this, the Great Mega King, memorized. But you have to do that. You won't, I will not give that to you. All right, so number 3 is one of our fun ones. So again, start off with what you know. So you know you have 10 pounds for every inch squared. And again, don't let these intimidate you. Sometimes they do look a little daunting at times, but they're not that bad, to be honest. Again, it doesn't matter which one you want to start with. It's up to you. Actually, I'm going to scoot this down just a little bit. Just a hair. In case I need more room here. Okay? So in this case here, I've got 10 pounds. And if you want to, you can, we're going to milligrams. I'm going to do the mass first. And it doesn't matter which one you do first, but I'm just going to pick the mass. So I'm going to move pounds. And I'm also going to write the units first. And keep in mind that I do have this information right here, which is going to be really helpful here. And we don't want to come up with creative conversions. So we're going to go from pounds to milligrams, but we first have to go through grams, okay? So whenever you're doing your conversions, always look at your conversion table and say, well, what did Mr. Craig give me? Because if he didn't give me a conversion, I'm not going to get creative and say, oh, well, there's 2.2 pounds in every kilogram. That's an approximation. That's not an exact bag. All right, so if we were to stop right here, the pounds would be gone. But again, I haven't plugged any numbers yet. But we want to go from grams, in this case, to milligrams. So again, slide it diagonally. I'm going to put my grams here and my milligrams on top. And in this case, I do have my final unit, one of the units that I'm looking for. In this case is milligrams. Okay, so that's looking pretty good. All right, and now I'm ready, and I'm going to use a different color here. Now I want to take my inches squared, and I need to get it, since the inches squared is in the denominator, I need this in the numerator. So I'm not going to move inches squared down here. That would be a bad idea, because then I'd have inches to the fourth, which I have no idea what that is. So I'm going to put the unit inches up here on top, but I'm going to go linear first, because I want to get my conversions in order before I actually start doing the squares or cubes or whatever it is that I need to do. So again, I'm given this information here, this information here. And so I think I really only need this one right here. The 1 inch equals 2.54 centimeters, because I'm going to kilometers. So let's get to centimeters. And whichever one is bigger, and I'm going to go ahead and plug in the values now. So let's go ahead and go back and get these numbers. So which one's bigger? Pound, gram, and again, this came from the table right here. And then milligram, gram. Gram's bigger than a milligram. We just did that a second ago, so gram is bigger than a milligram, and there's 10 to the 3 of those. Okay, so we have 1,000 of those. So back to over here, I've got 1 inch, and there's 2.54 centimeters. But now I have to come back and look at my square over here. So I want to make sure that I actually square up my units. So I'm going to put green here. So I'm going to go square here, square that. When I square the unit, I also square the number. Okay? We have to square the number when we square the unit. Okay? So now I've got my centimeters, and what's nice is centimeters to kilometers, that's a metric to metric. So going from centimeters to kilometers, one more step and we're done. So move that unit diagonal, and we're going to put the centimeters in. We always want to move it diagonal until we cancel it out. So we want to move that out. So we're going to put that up. So we're going to put our centimeters here and kilometers here. Again, let's go linear first. So that means that I want to ask myself, which is bigger, kilometer or centimeter? Well, kilo is right here, and cente is right here. So we want to make sure that we get rid of that. Okay. So I'm going to go 1 here and 10 to the, so go back. Kilos 10 to the 3, centes 10 to the negative 2. So I want to make sure, whoop, do that. That's kind of cool. So I'm going to go from 10 to the 3, I'm sorry, 10 to the 3 to 10 to the 2, which is moving the decimal 5 times. So it's 10 to the 5. However, be sure that you're keeping in mind that this is a square, which means I need to square that as well. Okay. So now my units, my centimeters squared are canceled out, my inches squared are canceled out. So the only units that remain are milligrams and kilometers squared. So when typing all this in, and again, this is the big battle for some of you, make sure that you're using your calculator correctly. So we want to go and say, okay, well, I've got 10 times 454. Again, I'm doing the top line first, times 1 E3. Okay, that represents 10 to the third. Now, here's what gets really hairy. Order of operation for your calculator is very, very particular. So if you are using a caret button, you need to employ a set of parentheses right now, which would be 10 caret 5, close the parentheses, and then square. If you do 10 caret 5 square, then this right here registers this as 10 to the 25. So you have to be aware of what your calculator is doing for you. So be sure that you're doing your calculator correctly, and I'll show you how I put the EE in because I want to be consistent on that. So 1 EE, and the beautiful thing is if you use the EE button, the EXP button, the times 10 button, you know what? When you hit x squared, the calculator already knows that this right here is 1 times 10 to the 5, and if I'm squaring it, then it automatically does this for me. That's why those calculators are nice, and that's why I highly recommend you learn how to use the EE button, the EXP button, the times 10 button, because it's going to make your life so much easier. All right, so we've got the top. Oops, put it back. So x squared. So that's everything on top. And I'm going to hit divided by. Let me erase this. Okay. So I'm going to hit divided. Once I hit that divided button, open up the parentheses for on the bottom. And the nice thing is we've got a 1. We don't care about that. We have a 1 squared. So really all we have is 2.54 and then square button. And when you type all that in, you should get 7.04 times 10 to the, what is that? Positive 15, which is in milligrams per kilometer squared. Okay. There's a lot going on there, but this is how you earn a lot of your points. All right, so let's take a look at number 4. Number 4 is going from pounds to kilograms, and again, I insist that you use these conversions. You are not allowed to say that there's 2.2 pounds in a kilogram. If you do, you'll lose a lot of points on this one. So again, start with what you know. So you have 120 pounds, and it wants to know how many kilograms. Okay, so it looks like we're going to use this conversion here. So if it's not the unit you're looking for, slide that baby diagonal. So I'm going to put my pounds on the bottom, and I'm going to convert that into grams. And then once I have my grams, again, slide that unit diagonally and put your grams down there. In this case, we're going to kilograms, so we have our units already in place. Okay. So once you do that, and some of you may favor that sort of system by writing the units down first before you go and plug in numbers. It just gets a lot easier. So 1 pound equals 454 grams, which again is that conversion right there. Kilo is bigger than gram. Why? Because kilo is right here and gram is right here. So we want to make sure that we're keeping that in touch there. So, and remember that when you look at this, since kilo is 10 to the 3, that means that there are 1,000 grams in a kilogram, not 1,000 kilograms in 1 gram. Okay. All right. So now that we have our values, make sure that we can type this in. 120 times 454 times 1. We're not going to do that. Divided by 1 EE3 or 1,000. And in this case, this equals 54 and I believe a half. Yeah, kilogram. Okay. All right, let's take a look at number 5. Here's another double-decker here. And so we've got, let's start off with what we know. We've got our 45 grams per inch cubed, which is okay because that's going to be as ugly as it gets. We can deal with that. All right. So again, doesn't matter with which one you start. This time I'm going to start with inches cubed. And it doesn't matter which one you start with. I'm not going to know which one you begin with because I'm only going to see your final product. So if you start with the grams, more power to you. So I'm going to put my inches cubed, or I'm sorry, inches on top. And since I'm going to nanometers, again, I have to use this conversion here. Okay, so be sure that you're using the correct conversion there. I'm going to put centimeters, but again, I'm going to go linear, and I'm going to put in 1 inch is bigger than a centimeter, and then I go in cube these up, cube the number and the unit. Have to do both, all right? Once you do that, probably not a bad idea, zap that so you don't have to look at that again for a while. And then, since we want to, we're still working from the bottom, we've got to move that unit diagonally or multiply it on both sides, however you want to look at that. So I'm going to go centimeters to nanometers, which is good because now we're metric to metric zone again, okay? So centimeters to nanometers, that's a good thing to be in. And then ask yourself, which one's bigger? Well, centimeter is farther to the left, centes here, nanos here, okay? And then so we're going to have 10 to the something. So going from cente, 10 to the negative 2, to 10 to the negative 9 means we're going to move our decimal 7 times here. Okay? So 10 to the 7. However, we are cubed, so that means that I need to cube this and this, wrap this up. And if I were playing at home, this would be 10 to the 21. Not 10 to the 10. Remember that when they're outside the parentheses here, that they're actually being multiplied, not added. Okay. So, cube that up. Like that. Okay. And so we have our first one completed, and it probably wouldn't be bad to cancel that out. All right, so now going from grams to pound, it's a one-stepper because there's our conversion right there, which is nice. Okay, so we're going to move the grams diagonally, and again, keep that in mind. You are moving diagonally. Not diagonally down, not diagonally up, diagonally. So if grams is up on top, it's got to go down on the bottom. Okay, so let's put grams down below and pounds on top. Which one's bigger? That's right, pounds. There's 454 grams in a pound. And since we now have our units that we're looking for here, so we've got our pounds and our nanometers cubed, we are ready to calculate. Okay? So the way to type this in, I would say, well, it's nice because they're all ones on the top, so that makes it really nice. So 45 divided by, open up the parentheses, because you've got a lot going on down here. So So we've got 2.54 caret 3 times, and again, use your EE button, EXP button, but if you're not using your EE button and you're doing a caret, then you would go 10 caret 7, close that parentheses, caret 3. Okay, that's pretty complicated, but I'm not done yet. And then I'd multiply that times 454. Okay. Then close the parentheses and hit equal. So that's one way to type it. But again, I'm not a big fan. Where I'm going to implement here or change is instead of doing this, I'm going to do 1 EE 7 caret 3. Okay. Whatever I've crossed out in the green and rewritten down here in the green, okay, these two things represent each other, okay, when calculating. Okay, so whichever one you're most comfortable with. When you get the calculation completed, you should get a value of 6.05 times 10 to the, what's my calculator say, negative 24, and that's pounds per nanometer cube. Okay. So again, a lot going on there. And then again, these double deckers are really the fun ones here. Okay. So make sure you can do this. Don't let those freak you out. Number 6. We have a decimeter to megameter. Hey, that's a metric, brother. That is one stepper. So start and don't let the exponent freak you out. It's just a number, guys. That's all it is. And what I'm not going to do is put like point and a whole bunch of zeros and then 235. This is a legit number that we could be working with. So make sure that you can handle it. So start with what you know. Okay. So 2.35 times 10 to the negative 11. However, you're going to type that in on your calculator. It's fine, just as long as you're doing it legally. And since this is going from deci to mega, that's a one-stepper, guys. Whoop, I didn't put my unit in, sorry. So let's put the unit in. Would be a good example here. Okay, so again, we want to get rid of the unit by moving it diagonally. Okay, so put deci down here, mega up on top. Which one's bigger? Well, I hope it said mega. Mega's right here, and deci's right here. So how many times do we move from deci to mega? Hopefully you said 7. That would be a good value. Okay, so, oops, turn it up. Yeah, so mega and deci, 10 to the 7. And guess what? We're done. We're ready to calculate. These metrics are fun. So if I'm trying to do mental math, which can be dangerous, let me remind you, if this is a negative and this is a positive, which it better be a positive within the word, okay, what we're actually doing is we're doing negative 11 minus 7, because when you divide by an exponent, then that means that you've got a negative value. So our number should be 2.35 times 10 to the negative 18 if we did this correctly, megameters. So here, let me actually show you how to type this in. So let's see. Here, let me erase you first. So 2.35 EE negative 11 divided by 1 EE 7 close the parentheses. And you know what? Not a bad idea. Every single time that you hit or type in your divided, the next thing you should type is a parenthesis. And it is. It is 2.35 times 10 to the negative 18. That's meters. Okay. All right. Let's look at number 7. Going from mile to millimeters. That's a fun one. So again, start with what you know. So if you ran middle school, oh no, check that. That I was thinking 3 kilometers, not 3 miles. In middle school, you don't run 3 miles. In high school, you run a 5K, which is just a hair over 3 miles. So apologize for that. 3 miles. I want to know how many millimeters that is. So again, we need to move the unit mile diagonally. Okay. So we'll put mile down below. And I am going to write the units out here. So we need to go from miles to feet first. Don't you dare go to kilometers. So feet. And then we'll convert the feet into inches, which I've given you there. So feet in inches. And then we need to cross over from the English system to the metric system. So we're going to move inches down. Whoops, sorry, wrong color. Inches down. And we got to go to centimeters. And since we're going to millimeters, we only have one more step, which is nice. So centimeters will move diagonally, and we'll put millimeters right there. And then we have our unit that we're looking for. So we've got our units all set up. So let's plug in some numbers. There's 1 mile, there's 5,280 feet. In 1 foot, there are 12 inches. In 1 inch, according to my, conversion here, sorry. According to my conversion here, there are 2.54 centimeters. And in 1 centimeter, centes here, millis here, negative 2 to negative 3 means that there are 10 milliliters in every centimeter. So 10 to the 1, we could say. Okay. So typing all that in, and again, not too bad. 3 times 5280 times 12 times 2.54 times 10. Let's just leave it at that. Or, if you're playing at home, 1 EE 1, and then take it 4. And when you finish that, you get a value for number 7 of being 4.83 times 10 to the 6 millimeters. Okay. All right. Let's look at number 8, liters to gallons. So in this case, we'll be using that conversion on our table. So looks like a one-stepper, guys. Going from liters to gallons, we don't have to do a whole lot. Start with what you know. So we have 2 liters, and let's move that unit liters diagonally. So we want to move liters down. So liters here, and again our conversion right there. But don't write just G, write at least gal. If you're going to write gallon, and don't write a capital G because that stands for giga. If you're just writing G, that's grams, and I don't know how you convert liters to grams. That's a no-no. So give me a gal at least. And then our conversion says that in 1 gallon we have 3.785 liters. Yeah, we're done with that one. Isn't that fun? Hopefully you'll see something like that. So we have about a half a gallon, so 5.28, I believe. Yeah, gallons. And that makes sense because again, we're a little over the 3.758. All right, number 9. Now we had 2 more. And again, hopefully you're trying these on your own instead of just watching me work these out. So start off with what you know. So we have 23.65 milliliters over an hour. Per hour, so that's like a flow problem, a rate. Since there is no squares or cube, I mean, really, this is a pretty fun one. So going from hours to seconds, I'm going to start with the time. So I'm going to move the hours up. Again, move diagonally. I'm going to start with the time here. So in every hour, be very careful. There are not 60 seconds in an hour. There are 60 minutes in an hour, but not 60 seconds. And I cannot tell you how many times I have seen and heard that. And then move your minutes up. Okay, so we're going to put our minutes on top, and then convert it into seconds, and we have our first unit. And then we'll go from milliliters to kilometers, however you want to say that. I don't care. So milliliters again, we have to move diagonally. So that goes down below. So milliliter, and it is a metric to metric, so you can put kilo on top. And we have our units that we're looking for. So we have our kiloliter in seconds, which is what we're looking for. All right, so let's plug in our numbers here. So we've got 1 hour is definitely bigger than 1 minute. 1 minute is bigger than 60 seconds. A kilo is definitely bigger than a milli. And again, kilo here, milli here, so we got 10 to the 3, 10 to the negative 3. Okay, so that means that that's kind of cool. So that means that we are moving 10 to the 6, 10 to the 6 times. Okay, so when typing this in, we're going to go 23.65 times 1 times 1 times 1 times 1, so don't do it, divided by 60 times 60, which is, if you're playing at home, 3,600. But hey, if you don't trust your brain, then trust the calculator. 1 EE6, close up that parentheses. And I want you to notice that I am only starting or using 1 pair of parentheses. I start with the parentheses after the division line or division sign, and then I put my other parenthesis right before I calculate. Okay, so don't get crazy and think you have to put parentheses everywhere. And when I do this calculation, I get 6.57 times 10 to the negative 9 kiloliters per second. Okay. Last but not least, that's a fun little metric to metric. So let's start off with what we know. 25.3 kiloliters. Kiloliters. Yeah, kiloliters probably the best on that one. And I want to know how many microliters that is, so move that kiloliter here, microliter there. Which one's bigger? Kilo is farther to the left than micro, so kilo gets the value of 1, micro's 10 to the negative 6, kilo is 10 to the positive 3, so that means going 3 times plus another 6 means that we're looking at 10 to the 9. And typing this in, 25.3 times 1e9, which should give me 2.53 times 10 to the 10, I believe. And that is in micrometers. Guys, I hope this video was helpful. If you have any questions, please don't hesitate to ask. But again, don't just watch this video. Try the problems out before you give up. These aren't too bad.